Hello everyone. Today we are going to start our last topic of center of gravity. In this topic we are going to calculate numerically find the location of center of gravity for different engineering shapes or figures, right? So we will start with a small introduction and after that we will go for the calculation part, right? Uh, Already maybe all of you have gone through this topic of center of gravity in your plus one or plus two. So no, the engineering significance of this center of gravity is very huge in designing of lot of components, lot of engineering components like buildings, bridges, machine components. Uh, Theoretically, it's a point where we can assume that the entire mass is concentrated about that one single point, right? So finding that single point is very important because all the forces they will be acting through this point. The gravitational forces will be acting through this point, and any other external forces they are also very significant. And the location of center of gravity, it will decide the motion, the bending, or lot of things that will happen to the product or to the component. So finding this center of gravity is very important. So we denote it with the symbol Cg or simply G also, right? So this is also termed as center of mass also for three-dimensional parts or figures which are having some weight or mass. So when we are talking about academics, we will be doing it on a paper like on the plane figures, right? On your paper or the whiteboard. So we call it as plane figure, which is having no mass, right? So that thing that we are solving will have only area. So we will be finding it with the help of area only, without any mass. So that is also termed as centroid, right? So we can also use center of gravity or the term centroid. So these are few examples which can happen in day-to-day life also in different engineering applications, automobiles, buses, high-rise buildings, cars, human body, and lot of machine components. They are very critically designed with the help of CG. So the position of CG is very critical. So uh, you know the, each and every application of CG is very tremendous, right? In aircraft application also, this CG point, the point where CG lies, is also very important. Location from the front, from the back, from the center. So it decides lot of things regarding the flight, right? So it will decide the balancing, the drift or the draft that the aeroplane will be having. So it will decide lot of things, right? The thrust, the center of lifting, the lifting point, it will be here. And any wind or any forces that are happening to this part or entire component, again it will be depending upon the CG also, right? So it decides the balancing point of an object. You might have tried to balance a scale or any object from the center on a single point or on your finger, right? So that is basically your CG point where you can balance any point, right? Of course, the mass is present at all the positions, but that is the single point where you can balance that object. So it decides the balancing point of the object. Another thing is, if we are applying force at center of gravity, right, it will cause pure translation. Pure translation means it will do the motion or displacement and produce pure acceleration, right? If we are putting some force away from the CG, it will cause some rotational moments or torque. So this point is again important, right? And the body will stay balanced when we are applying force on this center of gravity. Okay, so this is more concerned regarding bending of some products or bridges, machine components. We calculate moment of inertia later on, but for calculation of moment of inertia, right, we need the centroidal point. We need the point this single point or CG point. So calculation of moment of inertia is very critical, and for this calculation, we need the centroid, right? So now we are more concerned about the calculation part, how to find the location of CG, how to locate CG from different directions, different locations. Uh, in the upcoming slides, few minutes, we will see how to find the CG of simple figures and some engineering shapes. Right. Before starting, we will see some plane figures or simple shapes like rectangle, we have triangle and semicircle. So these have predefined locations of center of gravity. For example, this rectangle having length L and the other dimension h. So the center of gravity will be lying here at this dot point, G point. And if we say what is the location, it will be L by 2 and h by 2. That is length by 2 and h by 2. Okay, so this is how we can locate, we can say that this is L by 2 away from one side and h by 2 away from the second side. Similarly, for a triangle, if we have a triangle and we have to find the center of gravity, it will be lying at h by 3 from the base. From the base, it will be at h by 3, where h is the height of that triangle. For a semicircle having radius r, so it will be lying this point G. Here we will have the CG point, and if we want to find the dimension or the location, this will be 4r upon 3 pi, where r is the radius of this semicircle, so we can find this location, right? So we have few more figures like trapezium. The location of trapezium will be h by 3, b plus 2a upon b plus a. So here this trapezium will have its center of gravity. For a hemisphere, this will be 3r upon 8 from the base. This will be the base, and the height of CG point, it will be 3r upon 8. R is the radius, and of course it will be lying at the center. If you talk about the other axis, it will be lying at the center. Here also, it is lying at the center of the trapezium. So these are the points that we have discussed, the center of gravity for rectangle, triangle, and other shapes, right? So basically we have to find the center of gravity, not for the simple shapes, these are predefined, but we have to calculate the center of gravity for different figures, different shapes, complex shapes, and we need to find the center of gravity, right? So there is a method to find center of gravity. We call it as the moment method. So we have to basically calculate all the moments. We have to divide our figure. The basic idea is we have to divide any given figure into number of simple shapes, small shapes. We will convert the given shape into simple shapes, and then we will take the moments, right? Moment of each and every figure, each and every shape. Okay, moment will be here. It will be mass into distance. Okay, moment is force into distance or mass into distance. Okay, in our case we will have area only, so we will take area into distance, right? So we will use this method, and in the upcoming slides we will discuss this thing. So we will use this method to find moment for all the shapes, and then we will divide all the moments by individual mass, and in our case we will divide by the summation of all the areas, the total area, right? So this entire process will be divided into 4 simple processes or 4 simple steps. So we will start with the step 1. So for any given shape, let's say we are given this shape. This is some shape which is a combination of uh, rectangle and a triangle, some shape looking like this. So the first step will be we need to define the axis of reference, right? We need to define two axes, right, which will be our reference lines. So with the help of these two lines, we are going to take all the dimensions from these two lines. For example, here it is shown in this red colored dotted axis. One is x line and y. These are the two axes, x and y axis. These will be our axis of reference, right? And generally we take the lowest line, the lowest point of the figure, point or line of the figure. So this is the lowest point, right? So extreme bottom, we will take this point as an x-axis, right? So all the distances will be calculated from this axis only. And the extreme left point of the figure shown here, it will be taken as the second axis of reference, and we will take all the x distance from this axis only, right? So this is the first step and very important step, because we need to specify the distance from one single point only, right? So all the distances shall be measured from these two axes only. The y distance will be calculated from this axis, and all the x distance, the distances in x direction, will be calculated from this axis, right? So the extreme left line, left point, and the lowest point of the figure, these will be the two axes of reference, right? So let's say a few more figures, how to find the axis of reference, or your step 1. Okay, so for the first figure, so this will be, here you will have the lowest point. So this will be my first axis, okay, and this will be your second axis. These will be corresponding to the second axis, right? Similarly, we have some engineering shapes, T section or I section. So extreme bottom part, it will be the first axis, and the second axis will be this line, right? The lowest line of the figure and extreme left line of the figure. Similarly, for I section, it will be here and this point, right? So this is the first step, defining the axis for any given shape. You will be given a shape with the dimensions. So first thing is you need to define the axis, right? Then we have our second step, that is dividing the figure. So any given shape or any given figure, so we are taking again the same examples. So the step 2 will be dividing the figure into number of simple shapes. So we can see that this shape can be divided into three different shapes. It's a semicircle, rectangle, and a triangle. So we can divide this shape into small number of simple shapes, right? So we will have the first shape, that will be semicircle. Second, we will divide it into a rectangle, and third, we will have a triangle. So this shape is the second step is dividing your shape into number of simple shapes. So here we have three different shapes. Okay, this is the second step after defining the axis. Okay, in the second figure, which is a T section, so we can see this is a combination of two rectangles. So we can divide this into rectangle number 1 and rectangle number 2. So this is number 1 and number 2. So rectangle 1 and rectangle 2, right? In the third figure, we can divide it into three rectangles, number 1, rectangle 2, and rectangle 3. So this is your second step. So you need to divide your shape into number of simple shapes, right? Now this is the important step number 3. So where we need to find the location, right? Find the location of individual center of gravities, right? We need to find the center of gravity of individual figures that we have divided, right? We have divided into small figures, and we need to find the location of each and every figure, the CG of each and every figure. That means we need to find, let's say we have three figures, 1, 2, and 3. So we need to find x1, x2, x3, and y1, y2, y3. x1 and y1, these corresponds to the x and y distance of these points. Okay, so let's see the first figure. For example, we have the first figure. So we have defined the axis and we have divided this into three simple shapes, right? So what we need to do is, so we know the semicircle will have center of gravity at this red color point, right? So we know that center of gravity for a semicircle, it will be lying here, right? Similarly, for a rectangle, individually, rectangle will have center of gravity here shown in the red color point, and for the third figure, so it will have the center of gravity here. We are talking about the individual center of gravities for the simple shapes, right? Now we just need to find geometrically the distance x1, x2 and x3, right? So this distance from y line, this will be x1. So geometrically we need to find the distance x1, right? Similarly, x2 will be the distance of this point, the second figure, from your axis of reference. Remember, all the distance that we have to find, it will be from one single reference axis. So this will be x2. Similarly, you need to calculate x3, right? So I hope you can calculate geometrically what will be the distance x1, x2 and x3. We just need the dimensions and play with these dimensions, and we can easily find the value of x1. Okay, for example, we know that this point is 4r upon 3 pi. This distance is 4r upon 3 pi from here to the baseline. This is a baseline, and the distance from this point is 4r upon 3 pi, right? We know this distance, but we need to find x1. So x1 will be the total distance, this total distance minus 4r upon 3 pi. So we can find x1. Similarly, x2 will be, this will be half. From here to here, it will be length divided by 2 plus this distance. So from here to here, it will be this radius plus half of the length rectangle. Okay. Similarly, we can find x3 also. Okay. Now we need to find similarly y1, y2 and y3. y1 corresponds to the distance of this point, this individual CG from this axis. So this is your y1. So this will be at half of the semicircle. Similarly, y2 will be this distance. Again, this will be at half of the rectangle, right? And third, we need to find y3. So y3 will be this distance. So you know this will be h by 3 from the base of rectangle. So the total y3 will be h by 3 plus this distance. This is the height of rectangle, this dimension plus h by 3. So this will be your y3, right? So that completes your third step, finding the individual center of gravity x1, x2, x3 and y1, y2, y3. Okay. So after that, the step number 4 is you need to find the areas, individual areas. So area of semicircle, area of rectangle, area of triangle. You need to find area also, A1, A2 and A3, right? So area A1. So for the semicircle you can find area, similarly for rectangle and triangle, find the areas. Okay, once you are done, that is all for the calculation part. So what we have calculated, you can make a table like this. So we have three figures, semicircle, rectangle and a triangle, right? So we have, for the semicircle, we have calculated area A1, x1 and y1, x1 and y1 for the semicircle. Similarly for the rectangle, we have calculated area x2 and y2. Similarly for the triangle, a3, x3 and y3. Okay, so we just need to plug in these values in these formulas to find x bar and y bar. X bar and y bar, these are the locations or your final answer of center of gravity. This will be the position of center of gravity for the entire figure. Okay, this will be the x dimension. So how to find x dimension? This is a1 x1 plus a2x2 plus a3x3. It goes up to number of figures. If you have two figures, it will be up to 2 only. If we have three figures, it will be up to 3. If we have four figures, it will have a4x4 also, right? So a1x1, a2x2 plus a3x3 divided by a1 plus a2 plus a3. So solving this equation, this will give you x bar. X bar is the center of gravity location for all the combined all three shapes, right? Similarly for y bar, you need to do a1 y1, a1 into y1 plus a2 y2 plus a3 y3, okay, divided by a1 plus a2 plus a3, right? Once you are done with the calculation, you will get x bar and y bar. Okay, so let's see another figure. It's a T section. So the first step will be finding, after defining the axis of reference. Of course, that is the first step. So taking the axis of reference, find the location of individual CGs. So CG for the rectangle number 1 will be lying here. Rectangle number 2, it will be lying here, right? So we need to find x1, x2. So we have only two figures. So we need to find x1, x2 and y1, y2. Right, so from this reference, this will be x1, this distance. So this will be half the dimension of this rectangle, L by 2, and then we have this dimension, this is x2. So again you can find the distance from here also, okay, and y1 will be the distance of this point from the base, right? So y1 will be this distance, this dimension of the rectangle plus half of this dimension, half of the width of rectangle. If this is 20 mm, this will be 10 mm, right? Half of this dimension plus this entire dimension. So this is y1 and this is y2. So find y1, y2, okay, and again calculate areas a1 and a2 for rectangles, length into breadth for the second rectangle a1, a2, right? So you have find x1 y1 and x2 y2 also, and plug in your values in this formula. So you can find y bar, that will be a1 y1 plus a2 y2 divided by a1 plus a2, and similarly you can find x bar also. So for the I shape, we have three rectangles. So find x1, x2 and x3 from the single reference, right? Similarly find y1, y2 and y3, that is your individual location of CGs, okay. Then calculate areas for the three rectangles a1, a2, a3, and put your values of x1, x2, x3 here to find x bar, and for y bar it will be y1, y2 and y3. That will be a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3, right? So when you have symmetrical sections which is symmetrical about one of the axes, so the CG lies on that axis of symmetry, okay. So if the T section is symmetrical about this point, so this CG will lie on this axis. So we just need to find the height or y bar only, okay. So let's see a practical problem. We have a T section 100 mm by 150 mm, 100 by 150 by 30 mm T section to find the CG, right? So it will look like this. So we will follow that procedure, defining the axis. We will define the lowest point and the extreme left point as our reference, okay. So what we need to find, we need to divide it into two rectangles, rectangle number 1 and rectangle number 2, okay. So for the first rectangle, calculate A1, that is the area, 100 by 30, 3000 mm square. Y1 is from this point to the bottom, from here to bottom. So find this distance. It will be 15 mm from here plus this distance. So this will be 135. Similarly, for the second rectangle, calculate A2, length into breadth, area, and Y2. Y2 will be, the center of gravity will be here. Okay. So this section will be 150 minus 30. So this length will be 120, and this half will be 60 mm. Okay. So that is your Y2. So now plug in your values, A1 Y1 plus A2 Y2 upon A1 plus A2. That will be your center of gravity, Y bar. Okay. This is symmetrical about this axis. So